Yeah, my name is Claus Gravenhorst. I'm Director of Strategic Initiatives at CCS. CCS main focus is in supplying software technology for digitization and document conversion, but we are also engaged as a service provider in mass digitization projects. The title of my presentation is Applied Impact, and the key question is actually, does the new fine reader engine and Dutch lexicon increase OCR accuracy and production efficiency? So, an overview to my presentation. I will talk about the scope, a bit general about improving text accuracy. I will describe the test material, as well as the test system. I will talk about the provided impact tools we use for this test and how we integrated those tools with the test system. I will outline the test scenario and describe the evaluation method, and then finally come to the interesting part, the evaluation results of that test, and then finally conclude with some major messages. So the scope of the project CCS was in contact with the Impact project from the beginning. We were always interested in testing results from that project in a very early phase. So as fast as possible to really get hands-on and test those tools in a real production environment. Amongst other things, Impact then provided to us improved OCR technology as well as historical dictionaries. And as already has been mentioned, a good message is there's not only one, there are 9 European languages covered by historical dictionaries. So the motivation of CCS to have this joint case study with the KB was to benefit from those technology improvements, because we constantly try to increase the level of automation for our digitization workflow, which then covers small, mid, and large-scale digitization workflows. And we want to prevent from reinventing the wheel in specific areas, such as OCR and language technology. So briefly talking a bit about how to improve text accuracy, and this has already been mentioned a bit. So I think we can state that various pre- and post-processing steps, as well as extension of the OCR itself, have an impact on the text accuracy. And as we heard in the talk before from Apostolos, the image, this is really the key. The image that you are processing should be of best quality, or let's say as good as possible. And then the subsequent steps, they depend on it. So things like image preprocessing, where we do deskew, cropping, dewarping, etc., but also segmentation and layout analysis of the pages, where zoning is performed, as well as classification, ordering, grouping of page elements. And the OCR itself, the text accuracy can be improved by applying dictionaries, but also in some cases for very special fonts apply pattern training. So this will improve text accuracy. And finally, in text correction, again, dictionaries can be used, as well as additional linguistic methods, and crowdsourcing for manual correcting the text. So this all give extra improvements to text accuracy. So who at the end really benefits from those improved text accuracy? In first place, it's information retrieval. You will get a cleaner index and the user will have more relevant hits. So talking a bit about the test material we worked on, these are 17th century Dutch newspapers. They are printed with Fraktur and Gothic fonts, so we really concentrated on this difficult part of the documents. On one hand, we got material from the current mass digitization newspaper project from the KB, which is called Triple D, Data Bank of Digital Daily Newspapers. So we used 144 pages, equals 73 issues, and it's dating from 1619 to 1635. And the pictures are 24-bit color, 300 dpi. So this is a typical page from this publication. We have 2 columns, and if we zoom in a bit, we see the typical Fraktur Gothic type fonts and all the problems with that, the special characters, ligatures we have here between F, S, and L, I, J, and all these things, which make OCR really a different job. And we also got the impact ground truth material. So if we just concentrate on Fraktur and Gothic fonts, we got 72 pages, but we found out that there was an overlap with the DDD pages. So there were really common issues, and we did some small tests on DDD and GTM material. So it was captured, it seems to be captured with the same camera, but saved with another imaging tool. And also, if we look to the ground truth material, nearly every zone, because of the segmentation, is a polygon zone. And sometimes OCR doesn't like polygon zones. So we found slightly differences, and because we had the overlap, we decided to run our test only on the DDD images, which were 144. So the ground truth material beside the images also offers this page XML file, which has the segmentation zone coordinates we just saw on the screen dump, as well as the key text. I guess this has been keyed in by an offshore service provider and forms then the ground truth material for the impact project. So which kind of test system did we use? It's the DocWorks technology. This has been developed by CCS. It's a large-scale digitalization workflow. It had been developed during the EU-funded research project called META-E, stands for Metadata Engine. That project was from 2000 to 2003. And just to mention, also Abby was a partner in that project. Abby, for the first time, worked on Fraktur Gothic recognition in that project, and now again in the impact project, but also beyond that with other historic fonts. So the DocWorks system itself, in the market, it's used at many institutions and service providers worldwide for small and large-scale digitalization projects. And as I said, we are also or were engaged in mass digitalization projects, like at the British Library. We did the 100,000 books for the Microsoft-funded project as well. We are engaged in the newspapers project. Richard Boulderstone mentioned the project together with Bright Solid, where they intend to digitize 40 million newspapers. So DocWorks is used in that project as well. We use the technology for the KB DDD newspaper project, which will end of this year or beginning of next year. And we also use that technology together with the content reseller ProQuest. They are running the Early European Books project. And again, DocWorks is used there to digitize and convert historic books. So this is more or less the workflow, what it's all about. So it covers workflow as is needed for mass digitization. It covers item tracking. It really tracks the books coming from the shelves, going to the digitization process, back to the shelves. So it includes the controlling of the scanning process, and it includes the controlling of the OCR. It offers quality assurance, even distributed offshore, remotely, and so on. So it's really a mass digitalization workflow. And we use that system really to integrate impact tools and run the test with this kind of tool. If we look a bit closer to the conversion itself, I mean, we have the image preprocessing, but we didn't apply very much different image preprocessing features because we want to concentrate on the OCR part itself and the dictionaries. And next step then is layout analysis in this process, really to find the blocks, the page segmentation, to find the zones and classify those zones. DocWorks has its own segmentation method that we developed and implemented. So we will find all the blocks on the zone, bring it into the right order, classify those zones, and then once classified and those blocks classified as text zones, we will then just pass to the OCR and ask the OCR engine to give us the text for those page zones. And then at the end, we can do structural analysis with all these three results. So this is how it looks like if we do a screen dump from a processed document. So one page of this old Dutch newspaper is down to article level. So we will recognize an article. We have the different paragraphs here. We have the headline. And as you can see the difference to the segmentation of the ground truth material, we have polygons only in certain cases where really a polygon is needed. In other cases, we just try to set rectangles. So the provided impact tools, on one hand, we got the Abby Fine Reader Engine 10, which we already integrated to the DocWorks workflow, and there's an extension for Gothic Fraktur that we used. And what is very nice, there's a standard interface for the integration of the external dictionary. So we did this with a Dutch dictionary, but as we know that there are 8 other European dictionaries, these could also be integrated by just using the standard interface. So we got a corpus-based dictionary, Dutch dictionary. We also got a dictionary-based dictionary. Both are covering 16th to 19th century. And we also got a DLL, including a documentation to access those dictionaries and to integrate it into the OCR by using this external dictionary interface from Abby, and also to access additional routines for fixing misrecognition of long S characters that often appear in Fraktur material. So how did we integrate those tools with the test system? So we built a test system. We integrated the DLL with our DocWorks code. And through that code, we called external dictionaries via the external dictionary interface from Abby. During the integration phase, we found a minor bug in the Fine Reader Engine 10, but Abby gave us immediate support, provided a workaround, so we could start more or less right away. So at the end, I can say, or overall, I can say the integration went smoothly. So the test scenario, as I said, that there were some slight differences regarding the results we got from first testings. We then concentrated on the DDD material, so the 144 pages, because we had slightly better result with those pages. And then we applied at least some basic image preprocessing and our segmentation, for sure, our segmentation algorithms on that images. But regarding image preprocessing, we just applied cropping and deskew, not more. And then we did for a full run of the 144 images, we did a full text correction just to create our own, let's say, DDD ground truth material. So we had 144 pages corrected nearly to 0 errors, and that we used later on for the comparison. For the 4 runs we did with the DDD images, which were with Fine Reader Engine 9 and the standard Dutch dictionary that Abby is providing with Fine Reader 10, with Fine Reader 9, and we compared it to Fine Reader 10 with the standard Dutch dictionary. And then we used Fine Reader 10 with those 2 old Dutch dictionaries, including this long S fix. So the evaluation method was that our goal was to generate statistical data on one hand for character, but also for word accuracy, and that by running those 4 runs on the DDD material and then compare against the DDD ground truth material that we created. The computing then of the accuracy rates is based on the Levenshtein algorithm. The so-called Levenshtein distance represents the number of actions, so mainly insert, delete, and substitute of characters or words that are needed to transform one text into another. In this case, it means a faulty text or error-prone text into the corrected text. The Levenshtein percentage, which I will show later, is the value represented by the Levenshtein distance multiplied by 100 and then divided by the number of characters or words of the correct DDD ground truth text. So this is just a screen dump of the DocWorks text correction mode, just to show how this looks like when you look it up with the text correction mode. This is an uncorrected text that we show here. So because of the nature of the material and the image quality, there are failures in the text, but as you can see here, there in the third line of text, there's the word Deutschland. So we have there the ligature of S and L, and this has been recognized correctly without any text correction. So this is just an example how the OCR, together with the long S fix, can deal with such situations in a Fraktur or Gothic text. And just I marked it here, so the two words that you can see it better in the image as well as in the text. So now coming to the interesting part, to the evaluation results. So as I said, we did 4 runs with FindReader 9, Standard Dutch Lexicon, FindReader 10. So from left to right on the x-axis we have this. And then FindReader 10 and the 2 different dictionaries, the corpus one and the dictionary-based one. And I'm showing here, on one hand, the accuracy on characters, so the green-colored ones, and the light green ones are the numbers based on words. So on the y-axis, you have the Levenshtein percentage, and smaller values represents a higher text accuracy. So from left to right, this is showing an improvement. If we start with comparing FindReader 9 and Standard Dutch Lexicon and FindReader 10 and Standard Dutch Lexicon, we see that there is only a slight improvement. So the biggest improvement is really when you compare with using the 2 Dutch old dictionaries, and especially with the dictionary-based one, we got the best results. So if you compute these numbers, and especially if you compare FindReader 9 to Standard Dutch Lexicon and say this is state of the art, let's say this is 100%, and compare to what is the improvement in character accuracy on one hand and word accuracy on the other. So in character accuracy, we have 27.5% improvement. On word accuracy, this is 20.6%. So what does it mean in real life? So imagine you are processing a certain bunch of text with FindReader 9 and Standard Dutch Lexicon, and then you have to, for instance, correct 100 words. Then with FindReader 10 and the Old Dutch Dictionary, then you just have to correct 80 words, means 20 words less or 20%. But again, I want to highlight that we focused with this test just on the OCR and the dictionaries, not on image preprocessing, not on post-processing. So just a part of it. And Hilde-Lies mentioned that already in her talk, that text accuracy can be improved by applying these other things like image preprocessing and post-processing. And throughout the 2 days of the conference, I think we will hear about the research results in those areas. And Apostolos already told us a bit about image quality when created by scanning devices. So to conclude, I mean, the question was really, does the improved Abbey OCR and historical dictionaries help to get really a higher text accuracy? And the answer is yes. We have a higher text accuracy, and it will lower the effort for text correction. As we found out, the tools were somehow easy to integrate via the given DLL and, for instance, or especially, I must say, the Abbey interface for the external dictionaries, because it gives us really the possibility now to also use the other 8 additional lexicon so that future digitalization projects will benefit from these historical dictionaries. And by looking at the chart, so the results, the outcome of the test, I think at least based on this material and the outcome, we can say the biggest potential for further improvement is more in language technology. Thank you very much for your attention.